So in general, what this presentation is about is a general tick list of what I do when I'm building a data warehouse and how actually I automate most things, because the more I can be lazy, the happier I am. The more I can build ML, I'm quite happy. So it's all about automation, reducing your manual workload and using the inbuilt tools in GCP. A lot of these tools have got AWS ones, Simon, equivalents, and there's also Azure equivalents on here. So some of them, just there's a Google comparison sheet which I'll share out later, which is super useful to get some of the technology terms. Also, as many data type memes just to keep things funny. So I've been working with GCP for about 8 years now, and it has grown exponentially. It is now very accessible, it's very quick to run, and there's a lot more tools available. The documentation is awful though. So as we mentioned earlier, Medium is probably your best friend here. It is quite low cost, and there's a lot of free allowances, and there's a very active community to support. So when you are building your data warehouse, reach out to people, because there will be people who've been there, done it, and probably been bitten by issues with it. And in terms of what a data warehouse, I suppose most people might know what a data warehouse is, but it's basically where you keep data. It's where you access data, you can have backups, disaster recovery, BI, machine learning, data wrangling and analysis, but basically it's that centralized one-point stop for your data. And you can have multiple data warehouses for any company. I used to work for Lloyd's and they had a lot of data warehouses. And in terms of the tools, as I mentioned, there are an awful lot of tools on GCP. Many do the same things. Some require more code, some require less code and very easy to implement. And it's really working out what works for your company and what works for you as well, because some of this is very hard to implement when you initially start. So don't try to overcomplicate it when you first start building a warehouse, because it's very easy to do so. And in terms of first things first, as Liam recommended, as everyone knows, the Control-V keyboard, as Liam recommended, set up a project for fun, if you're that way inclined, which I assume most of you are. It's really useful to set up a project. You can explore, you can have some fun with your data, you can import projects. There's lots of data on Kaggle, and you can also use tools such as CodeGrapper, YouTube, Medium, GitHub, and Stack Overflow. All of these will help you actually work out how you build data warehouse and familiarize yourself with the UI. And the other big note on this is the UI is constantly changing. In fact, on a weekly basis with some tools like BigQuery. So keep looking at it regularly. The processes change and the availability of tools also change as well. But Stack Overflow it, honestly, it always helps. And still code from GitHub, because there's always people sharing BigQuery code and Python code to do things for, within GCP. So I'm not going to go too far into developing data warehouse because it is generally based on what data you have. But these are the 5 sort of rules of thumb that I follow when I'm starting to look at a data warehouse. Planning is very much key. Do not start anything until you've built out a plan or even seen a sample of your data. Testing, because this is from experience. You may think your code works perfectly, but when you start to go to stage in production, your code might not work and it will absolutely annihilate some of your wrangling and transformations that you do. Reviews and version control. GitHub is all I'm going to say here. Just use GitHub. It is great. But it also means the amount of time that you spend looking for codes, trying to find out where your base code is. If it's stored on GitHub, you actually have documentation to tell you which GitHub code you have. You branch into it effectively. It simply means you can find the code, which I recommend it for any code, including for your scheduled queries. Likewise, this is a relatively new feature with BigQuery. In the last year and a half, there's been a lot more scripting. So those of you familiar with Redshift and PostgreSQL, there's been a lot of SQL for many, many years now, including things like user-defined functions and stored procedures. But BigQuery is relatively new to the world of assertions and scripting automation. So this is a really key area, and you can basically write code for your reports or for your ETL to ensure that you don't actually ever have to touch your code unless things go very, very wrong. And likewise, keep checking the documentation that comes up from BigQuery, because they're adding a new feature probably about once every 2 weeks, all of which are super useful. So features like Soundex have recently come out and it saves a hell of a lot of time. As you're probably getting, I like being lazy when I'm programming if it's automated. And likewise, the communication. When you build a data warehouse, it's all well and good if you build the best data warehouse in the world, But if you don't communicate about it, no one's going to know what it is. So you do need to talk about what is in your data. Think about what other processes people are doing that are manual. Talk about whether it's even worth building a data warehouse for these people who are going to be your end users of the data, and work out what other data can be ingested, because it's not just about Google Analytics 4 data, which BigQuery has a tendency to focus towards. It can ingest all types of data, including emoji data, which is pretty fun to analyze and build models on, especially if you're doing sentiment analysis. You do get some really weird results on that as well when Apple release a new emoji. So as I mentioned, planning is key. Lots of data memes, as you can see. It is really easy to jump into data warehousing, and when you start looking at data, pull it into your data warehouse, have a play with it. But often, if you jump in too quickly and you haven't planned out how your data is going to scale, things need rebuilding. So for example, as Liam mentioned with cloud functions, if you have a source that you're reading in, you think this is fantastic, but later on realize that when it goes to scale and production, that your file is going to be absolutely ginormous, it's not the right tool for you. So planning, working out what actually is needed, and also saying no if there is a data source that you think this just isn't going to be used and it's not worth the time of ingesting at the moment. And the biggest question I always ask when I'm building a warehouse, because it is the buzzword at the moment, build your data warehouse, bring in your data and every type of data possible into your warehouse, is what is the point of it? Have a subject matter for your warehouse. As I mentioned with GCP, you can have multiple projects and multiple warehouses. You can have warehouses on AWS and GCP, which I'll go into a bit later. But it's just making sure that there is a topic and a reason for your warehouse and keeping that data quite tidy. So for example, you have a marketing data warehouse, which we tend to focus on at MeasureLab. Make sure that it retains a marketing data warehouse. And if you then need a different data warehouse, create a new project with that data. The other element is actually creating a one-stop shop. So this is actually away from any code. At MeasureLab, we actually created an admin portal, which was a simple Google site with lots of links, but it had everything in it. So it meant that both the developers, analysts, or even product users can go in and see where data's from, and also find out what it actually means as well. So automated data dictionaries, lots of tools like that can sit within a Google site, and it means it's highly accessible, because if the data is not accessible, no one's going to use it, and it is just going to be a pointless exercise. Likewise, also being realistic about what you can achieve with your warehousing, and also being flexible. Sometimes you might spend a month developing a great ETL process, and we've all experienced this at MeasureLab at times, and you find out later that this isn't the right approach for the client because the data is very different. Be flexible, be able and willing to change the approach that you're taking. So that was a very quick intro of approaching a data warehouse. But what I wanted to talk about today is actually the automation and management of the warehouse, because there's lots of inbuilt tools that will help you do this. So thank you, MeasureLab, for the infographic. But this is what once you've got your data warehouse built, it can get very messy. Now, anyone working with data knows very quickly a data warehouse can get very messy. And in fact, 28 days later is actually a realistic time frame. If you give everyone permissions and people building lots of tables, it can become an absolute pain to find the right data, and also actually find which tables are the right tables, and the SQL code or Python code that is building them tables as well. And once your data warehouse is out of control, it's very hard to bring it back. You can though, which is quite positive at least. So my top 5 tips on maintaining a data warehouse, and I'll be going through some of these, are table management, backup and scaling. So Google Cloud Storage, as Liam mentioned earlier, it's a fantastic data lake. And that data lake can be used for migration away from BigQuery if you do then decide to go to another source. And likewise, if you do put an error in your code that's bringing data together from lots and lots of CSVs, it's a great way to rebuild that. And likewise, scaling as well is be realistic about how much this is going to scale and how quickly it's going to scale. Have some control about the number of files that are going into your data warehouse. Metadata control. Now, this sounds really techy, but it's not. It literally is adding descriptions to tables, variables, and making sure actually you have some control about the standardization of what people are putting into your warehouse. So having a case sensitive side of things. So we use snake case, make sure everything's snake case, keep it consistent. Things like dates are the primary issue that I found in my life, is the fact that people write date as a word, DT, D, many different versions of dates, and sometimes it will be the first word, sometimes it'll be last. So having that consistency makes it a hell of a lot easier when you actually go to program against the data. And realistically, when you are building a warehouse or maintaining a warehouse, you really need to think about the end users, because they really don't care how you've got their data in there. They only care about the data you're actually getting. And then we have login. This is my favorite tool in GCP at the moment. Login, as Liam mentioned earlier, is a tool which tracks every transaction that happens on GCP, whether it's native to GCP or whether you use externally. So if you use Data Studio, for example, or Tableau, you can actually track that transaction. So whatever was done in Tableau against GCP, you actually know who's done it. So it's a great way of finding out who's spending what, and if there's any dodgy code going on, and who developed that as well. And then knowledge sharing, telling people again, just keep telling people it's there, because the initial communication is great. You get a big fanfare, you've got a data warehouse, but often people forget, new people start. So keep the communication up, keep sharing the knowledge. Don't become a spoff, because that often happens. And then controls. So control who can access and what actions people can do on your data warehouse and GCP as well, because it's key. It's very easy if you have the native controls of user, admin, and viewer, I think it is. You can easily get people building a lot of tables and causing a lot of issues in the endpoint. So the more you can get this basics sorted before you even start managing your warehouse, the better, really. So best practice. Everyone hates this term, but get best practice communicated out. So these are like schemas, making sure that you have consistency with all your tables, and pushing back to people if they do build a table that isn't quite in line with your process and your best practice. Talking and educating people. So at Measure Lab, for example, we have a header with every SQL script. We make sure that we have a schema where it's all lowercase and snake case each time. So it is really important that you maintain best practice and you're able to feed that back to people about the best practice. And there literally is an API for everything. I'm not even joking. If you go into GCP documentation, there is an API or cheat sheet for everything. And the great thing is, although the GCP documentation can be a bit iffy at times, they do share code, and often people will take that code, redevelop it and share it on GitHub, or my favorite Medium. So there's lots and lots available out there. So you don't have to build everything from scratch. It's about understanding where to look and where to pull information from. And likewise, there's a couple of great people who are building the community around GCP. And that includes Girl Dev, I think it's called Cloud Girl Dev, who has recently done pictograms of all the processes. And it's like me, you don't particularly like instructions. It's a great way to follow it because it's lots of images. You can follow it piece by piece. And it's also a really accessible tool to help educate you and get your certification if you're going for that as well. And as we mentioned earlier, the key thing for a lot of clients when we're looking at warehouses is the billing. So be able to communicate about your billing before you start, during, and actually automatically. So GCP actually provide a billing data set that you can ingest into BigQuery. It's a couple of clicks of the button. You can also ingest it into multiple other tools. So you can actually ensure that if someone accidentally does a query that's £250, no one at Measure Lab has ever done that, just to put that out there, you can quickly spot it and you can see exactly who has generated that query. It allows you to build up visualizations and reports outside GCP for people who are in finance or people who are not necessarily going to want to use some of the tools. And also saves you on education in terms of getting people up and onboarded on that. And likewise, they also provide sample code to do this. So the great thing about BigQuery in general is they have lots and lots of sample code. So have a look, because they probably have got sample code out there. But the biggest thing is communication about billing. Talk to people about estimated prices. So if you are now ingesting another data source, so if your client comes to you and says, I want to bring in this data source that's masses and masses of terabytes, you can actually use the GCP calculator to work how much that is. It's a great way of maintaining your data warehouse and ensuring you haven't got errant code going on. And I recommend doing a billing audit every 3 months because sneaky queries and sneaky processes do get in there, often for us playing with systems, but it is important just to double check. So data lakes, I forgot to delete this screen, but I'll talk about data lakes. Data lakes are the entry before we get into the data warehouse. And again, it's important to keep these clean. And the great thing is you can use tools like Colabs, which is a Python tool. It's an IPython tool, which you simply need to add the Chrome add-on, and you can get Chrome working. You can literally connect to BigQuery and some of the cloud APIs very, very quickly. And likewise, you can also use that to push data to BigQuery. You can then delete data from BigQuery, and you can also create buckets as well. But it is important to keep your cloud storage, tidy, because it is the precursor to your data warehouse as well. And it is very hard to find systems if you are looking for certain bits of data. If it's very clear where that is and you have clear documentation, you can rebuild the data set you accidentally deleted last week. So it's really, really key to have a really clean data warehouse and to have, data lake, and actually have the data lake in the first place as well. Something I did want to talk about, which is a relatively new area of BigQuery, is it's not just SQL. So I'm not going to go through each of these acronyms, but it's important to remember there are tools like DML, DDL, DCL, which I'm going to go into all these. There's lots of Ds and QLs, but ultimately these tools will help you build your SQL code and actually get to a scripting and DevOps approach as well. So DDL. This is my favorite part of SQL, as Liam knows. DDL allows you to automate things like table updates. It adds descriptions to variables and tables, and it also allows you to add partitions. If you get this right when you're building your ETL process, it saves you a lot of pain when you're trying to find out what on earth is the source of this data. And likewise, it allows you to establish what transformation you apply to a certain variable. So commonly you have the variable clicks. What is a click? Is it unique or is it actual clicks? You also then often need to know where the scheduled query is coming from. So use DDL as much as possible. And there are constant additions being added to DDL, which is data definition language, as you can see here. But it does save you a lot of time when you're managing a data warehouse to ensure that people actually can see what this is actually doing. And likewise, it allows you to then use other tools, which I'll talk about in a minute, called DML, the Ds again, which allow you to then actually pull this into automated tools like automated data dictionaries. And just to put an example here, now, just to warn you, BigQuery interface is changing literally every week. So it may not look like this next week, but for every table, you have a description for each variable. And you can either do this through the UI, or if you are using DDL, you can do it automatically, which saves a hell of a lot of time. And likewise, if you start to see tables where descriptions are dropping, you can actually go back into the code and apply the DDL into that as well. So as I mentioned, login, it's not about truths. It's all a tool called audit login in BigQuery. So it allows you to track every transaction that takes place in GCP. The reason why this is important, it tracks things like the cloud functions, it tracks things within BigQuery, it tracks any process that's running. So if your cloud function fails, it can create an error transaction. And that error transaction can then trigger an alert if you build that. So I've heard of clients using it as an email alert. And likewise, we use it in Measure Lab as a reporting tool. So we know when things aren't going quite right. We can also see user level spend as a result of the audit logs. So we can find out who's spending $200 this week and actually work out why they're spending $200 and feedback that query to them. The audit logs have great functionality. It can go into tools like PubSub. It can go into cloud storage. It can go into Python, but we tend to pull it into BigQuery, into a nested data set, primarily because GCP provide a lot of code that allow you to extrapolate that data into reporting as well. So really useful tool. There's also a no-code interface within the GCP dashboard, which allows you to quickly have a check what's going on and actually be able to reroute the data into BigQuery as well. So if you keep seeing errors come up, you can actually click on that error and build a code that will route the data into BigQuery as well. So it's super important to get familiar with login, and it's quite a hidden feature. So it's important to, again, with GCP, everything's quite hidden. It's important to have a look through the GCP interface and pull the details out of that tool and get familiarized with it, because it's incredibly powerful. Likewise, it can tell you who's using what tables and if the tables are even being used. So I'm guessing anyone working with data, how often have you built a table when no one is using it? This is a way where you can actually find out without having to email and canvas everyone, and that person on holiday doesn't get back to you and you delete that table. That's always a fun experience. So it's a great way of seeing what is actually being pulled off that table. And likewise, you can also see the last time that table was updated as well, and the dependencies of that table. So you can actually work out your dependencies in tables, and then actually work out if your change is going to affect other tables if you're changing your code for a data source. And as you see, I did get a bit meme heavy on this. The data manipulation language is what I mentioned earlier, but you can pull a lot of the metadata from this. And this is where you can actually start to make automated data dictionaries through DML. So with the combination of DDL adding description, you can then use DML to, again, lots of Ds, DML to actually pull the information that is on that back-end screen that I showed you a minute ago into Google Sheets or Data Studio or whatever tool you want to use to actually automate a data dictionary and centralize all your data to make it really easy if anyone's programming against that data to have a look at the different tables available. Likewise, it also allows you to do health checks and weather reports, so you can say when the last time that data was updated, and also see if the row numbers are changing, because commonly there will be no error for certain processes. It could just be an absence of data, and then you would notice your row numbers are not increasing. So that's where DML and data information schema, which is another cool term, which anyone familiar with SQL Server may know this, will bring back all the table information and who created the table as well. There are a huge amount of information schema options as well now. So again, GCP documentation, have a read through, and Medium will tell you how to actually use it for the most part. The other thing about information schema and DML is looking at regions. So BigQuery, data warehouses, and cloud storage are very much region specific. So it is important to understand what regions your data has been stored in. And as part of the management side of a data warehouse is to ensure no one's errantly put in a US data set when your data is all based in London, for example, because you can't join that data, and eventually you will have to either data transfer that data or build a new pipeline to actually move everything to wherever your data source is. So it allows you to actually check if someone's accidentally put something in the US without you having to click through the entirety of the interface to double check why data sets aren't working. In terms of sharing your knowledge, my top 5 tips, and I mean, I could go on about this for ages, but top 5 tips are to centralize information on your data and let everyone know it exists. So this is the reason why we use Admin Portal at Measure Lab, because we know that's one link that we can send out to everyone and they can have a read through and find out actually what's going on. They can also look at the reports that we build, like the automated data dictionaries that I keep mentioning, billing reports, health checks, and all the other processes. And likewise, it's a great place for you to store alerts for yourself to actually find out, rather than digging through and waiting for someone to message you, your director, go, why is this data all changed? It's a great way for you to preempt that and rebuild and sort out your data sources. And look for use cases where your data can remove manual tasks as well. So I think everyone's had this experience where someone's manually pulling a piece of data. So I use GA4, for example. Someone might pull a number every week, pop it into Google Sheet. That takes 20 minutes, which isn't a lot of time. But if you automate that, that could be something that saves over a year, hours and hours of time. So it is a great opportunity to demonstrate the value of your warehouse and get more people using your warehouse. It also often opens up new opportunities in terms of new data as well. So it's a great way of managing your warehouse and growing and scaling your warehouse. Visualize and use your data. BigQuery has a great tool which you click a button and it opens a Data Studio report. It makes it super easy for you to visualize your data and makes it very quick for you to then demonstrate what is in your warehouse. And likewise, you can also pull this data very easily into Python. So Colabs is a great tool because there's not much, you don't have to download or install anything, just that add-on. And you can then visualize through that tool as well. And there's great and easy connectors doing that. Ultimately, to get you in a good kudos is you save your company money. So if you're saving hours, you're saving your company money, you do more fun stuff, spend more time machine learning or doing some fun analysis, like the emojis, machine learning. And if you manage your warehouse effectively, you'll have lots of these reports, but it will allow you to automatically see what's going on. I highly suggest using things like Slack integrations, which allow you to then produce an alert. If there is an error on the cloud audit log, you can then do a Slack message, which will get you at 7 a.m., but you know what you've got to go and fix when you get into work. And Liam is our resident expert at IAMs, so he can probably tell you even more about IAMs than I could ever do. But IAMs are an absolute pain in GCP. There are so many options. I think, is it 3,600 at last count? Yeah, 5,000. So growing every day. So before you actually start to give people access to your warehouse, and when you're maintaining your warehouse, if you have control of who has access and do things like the Google groups or create roles, it does save you a lot of pain in the future. It also means that if you've got someone who's relatively inexperienced, you can control how much they can actually spend in GCP. You put caps on their usage allowances. And likewise, you can also put caps on the general usage of your projects and get emails when you're going over them caps. So having a really strong role-based process is really important. Google Secrets, service accounts being managed efficiently will save you a world of pain in the future. Service accounts are the worst thing and also the best thing at times. You just having Google Secrets are a great way of managing the SDK keys, the keys for these. It also means that you can actually ensure that people aren't sharing the service account and accessing your data without your permission. So having a good maintenance of that is great. And even better, as I mentioned, GCP have an API for everything. They have an API for managing the IAMs as well. So you can list who has access. You can also use audit logs to actually work out who is accessing your data as well. So using all of these, you're able to work out, should that person still have access to the data? And if they're not, delete them and hope they don't email you on Monday morning. So I'm going to go through a quick few what else is. So it's hard to break GCP and BigQuery. Quite hard. You can do it. You have to try quite hard. So with GCP and BigQuery, if you accidentally delete a table or you accidentally overwrite a table with maybe aggregated data or something goes a bit wrong in the morning, you can actually revert it back to the time point that you last knew that data was correct. So it's super handy to get familiarized with that, because you will get a panicked email at some point from someone going, I've deleted this table, or I've overwritten this table with the wrong project's information. So you can use that. And if you communicate out the disaster recovery, or if you're familiar with that, you can revert the table back really easy. It's a couple of lines of code. And it just means that you don't have that utter panic and the rebuilding time, which can take hours. And it can cost quite a lot if you don't know disaster recovery. The table recovery values are there. But you can delete a data set and not be able to get that back. So this is where the data lake comes in. There's no disaster recovery for data lakes at the moment. BigQuery and GCP also have inbuilt disaster recovery. So if something goes very wrong in the London servers go wrong and all data deleted, they have automatic disaster recovery processes. So back in the day, you used to have to go to a certain site with all your on-prem data stored. It's still got disaster recovery in the cloud. So it means it will be stored somewhere else in Europe. But obviously, as I mentioned here, try not to delete tables, try to keep controls, check your code before you run it as well. And there's always new tools. So BigQuery is one of the areas where they're constantly developing new tools. They're actually bringing them very much in line with SQL Server and Redshift, some of the features, taking the best features from there as well. So over time, we're seeing a really great development in terms of tools and availability of these tools, especially around scripting. And it is so important to check these because it can save a lot of time. I mentioned the Soundex function earlier, and that allows you to actually group channel groupings, for example, where someone's accidentally put the wrong name in. You can use Soundex, which saves hours and hours of hard coding, and also saves you time in the long run, actually then going back and hard coding that in the future as well. So check out the features, they're constantly developing them. And likewise for GCP in general, with all the warehousing tools, they're adding new features all the time. Cloud Functions are recently updated, and I'm sure there's going to be a lot more features soon. Although they still have not got a GitHub for the BigQuery code. So that's the one thing they're still lacking, and hopefully one day they will actually do that. So at the moment, if you have got a scheduled code, manually back it up to GitHub, because it's not backed up anywhere other than the audit logs. And then the one other thing that is growing in terms of GCP is a hybrid stack. So back in the day, you'd have AWS, you'd have GCP, or you'd have Azure, or whatever your platform was. Or you'd have different data warehouses that you'd have to combine via Python or SAS or R. Nowadays, GCP has actually developed a lot of tools that allow you to query data in your AWS interface, for example. So you're able to bring in AWS data and S3 bucket data very easily and program it together without duplicating your data. So rather than copying a table that's on your AWS cluster, you don't need to do that anymore. You can query that and then bring that into your BigQuery cluster as well. So you can bring them to query them together without having to manually migrate data or duplicate data as well. It means that you start to have a multi-cloud stack, which is very hard to say. And you basically benefiting from the best features of all the tools as well. So it's important to stay dynamic in that area to ensure that you're using the best tools for the job and bring them all together, because that's the whole point of the hybrid stack, is actually to bring the best tools together to meet business needs. And then one of the biggest words of advice I have, and this is from many years of experience of having things go wrong, is to automate everything you can. So these are things the check-in tables are actually updating, automate it. Making sure that you want to have descriptions to code, automate it. Because ultimately, as you can see from this lovely meme here, this does happen. It really does. So make sure you really understand your data and keep a full control over it with the tools that are available to you. You don't have to spend a lot of time with the controls. It's about building the right controls and working out where you have to intervene. So having the error login, for example, or knowing that the row numbers are increasing, for example. And avoid hard coding like the plague. So if you're building a Python script to ingest your data, try to avoid hard coding. Use the functions that are available to make it dynamic code. Script, use if loops, and make sure you're not hard pointing code to a hard table, for example. Oh, no, gone the wrong way there. And then final words, warehouses fail. They really do. So it's just being aware and having control and being able to get these back as quick as possible. So having your GitHub code stored means that if your warehouse fails for whatever reason, it's very hard to do this with cloud tools, but it can happen. You can then back up and revert all your data. And likewise, if you start using these tools over time, you spend less and less time actually managing your warehouse, but you do get in companies, you become the cloud guru. And it actually helps in terms of your reputation in the business, but also allows you to save a lot of time in terms of working with the data. As I mentioned, machine learning, do fun stuff as well. GCP is also designed to be very user friendly. It is a very quick system to get used to. I don't know AWS, so I don't know how that works, to be honest. But I know with GCP, it's very quick to get used to the tools. And as I mentioned, the community really do want to help. They want to build up the community on GCP. And finally, let the tools do the work for you, because being lazy analyst really does help.